Let's just go right into this. G of 4 equals, we're going to plug in 4 into all of our x values. So integral from 1 to 4, f of t dt. So integral just means area under the curve. So we need to find the area under the curve from 1 to 4, which is just all of this nice stuff right here. So of course we can't find it with our calculator, so we're going to find it geometrically. So if you notice, you can actually split this shape up into four different shapes. We have a triangle right here, a square right here, another triangle right there, and another triangle right there. So we're going to find the area of each of those and just add them together to get the area under the curve. So now I'm going to find the area for this triangle. So the area of a triangle, 1/2 times base, and the base is 1. And now the height, let's count it, 1, 2. The height is 2 units. Plus, now the area of this square right here, base times height is just 1 times 1. The base is 1, the height is 1. And now for that triangle, now for this triangle right here, 1/2 times the base is 1 and the height is 1, minus this triangle. We're minusing because this triangle is under the x-axis. So whenever a shape is under the x-axis, you have to subtract by it. So it's literally the same thing as the other one. 1/2 times 1 times 1. 1/2 times base times height, and the base is 1, the height is 1. So the 2's cancel out, so it's just 1 plus 1 plus 1/2 minus 1/2. So it's 2 plus 1/2 minus 1/2. Those halves are going to cancel out, so we have 2 as our answer for G of 4. Now for G of negative 2, you notice that we actually have a bigger number on the bottom of our limit, so therefore our answer is going to be negative. So knowing that our answer is negative, now we find the area under the curve from 1 to negative 2. So from 1 to negative 2, it's just this nice big triangle, so we lucked out. So it's 1/2 times the base, which is 1, 2, 3, times the height, 1, 1, 2, 3. And now it's negative 3 over 2 times 3 equals negative 9 over 2. That's our answer those are answers for part A. Change of G with respect to x at x equals 2. So whenever you hear rate of change, that means derivative, baby. So let's find the derivative of G of x. Now you'll be able to recognize that this will be a second fundamental theorem of calculus problem. So now you just take your limit and just plug it into the t. So it's f of x, g prime of x equals f of x. So and because x doesn't really have it does have a derivative, it's just 1, so it'd just be times 1, but you don't have to include that. You don't have to include that times 1. So now you plug in 2, and f of 2 equals, let's look at x equals 2. What is our y value? Ooh, it's 1. F of 2 equals 1. Let's go. Alright, see, find absolute minimum value of g on the closed interval negative 2 to 4. So when we're finding absolute minimum, we're going to have to take these into account. So we're going to plug in our endpoints into our function right here, or we're going to plug in any critical numbers that we can find. So let's find our critical numbers. So we learned from the last step that g prime of x equals f of x. So when does f of x equals 0? So we just set the derivative equal to 0. So when is f of x equal to 0? At x equals 3. So x equals 3 is our critical number. So we're going to have to evaluate g of x at negative 2, 4, and at x equals 3. So let's do that right now. G of 4, we knew from an earlier step, equals 2. G of negative 2, we know from an earlier step, equals negative 9 over 2. And G of 3, we actually don't know yet, but we're about to find that out right now to see if it's smaller. And now this is just the same as part A. We're going to just find the shapes find the area for the shapes under the curve from 1 to 3. So it's just this stuff. And if you have your work from earlier, you should know that it's just 1/2 times 1 times 2 plus 1 times 1 plus this triangle over here, which is just 1/2 1 times 1. So it's those 2's cancel out. 1 plus 1 plus 1/2. 2 plus 1/2. 5/2. So g of 3 is 5/2. So now that we have all of our answers, what number is the smallest? Because we're being asked for the absolute minimum value. So because g of -2 is our only negative number here, this is our absolute minimum value at g of -2 equals -9/2. Okay, now D is a very hard problem. But what I know for certain is that the answer is x equals 1 because I asked Mr. Torres and he told me, yeah, that was the answer. So let's just try our best to prove why. So we knew from our earlier step that g prime of x equals f of x. Let's find our second derivative. And to find our critical numbers, we have to set our second derivative equal to 0. So when is our derivative when is f prime of x equal to 0? And we're given the graph of f right here. So when is the slope 0? So we can see at x equals 1 that there's a horizontal tangent line, meaning that x is 0. I mean, that's the slope is 0 and f prime of x is 0. So that means that our critical number would be x equals 1. So but now we know for certain that that's the answer. But I'm gonna make a sign chart just in case things might have not been clear enough. So if I made this sign chart, and so this is what I'm going to plug in my numbers into. Let's plug in 0 right here. So if I try to look for at the slope at x equals 0, you could see that the slope is positive. So boom, and I'll just take 2 right here. So at 2. You can see our slope is negative, so f prime of x would be negative at x equals 2. So that is my best justification for why x equals 1 is a point of inflection.